Naming and writing formulas of acids. First off, what are acids? We learned about ionic compounds. They are formed of a metal and a nonmetal. Covalent compounds are formed of all nonmetals. But what about acids? Acids are compounds that involve hydrogen, which is a nonmetal, and some other kind of nonmetal, either a single element or a polyatomic ion. But it always involves hydrogen, so it's all nonmetals. And here hydrogen is acting as an ionic compound or an ion, donating an electron, becoming a positive ion. So acids are all nonmetallic elements, but it involves hydrogen, which to some degree is acting as a metal or as a positive ion. To name acids, we're going to divide them into two different categories, those that do not have oxygen and those that do have oxygen in them. To name acids without oxygen, you always use the prefix hydro and the suffix "ic" and something in the middle to indicate what element is combined with the hydrogen. And so hydrogen and chlorine becomes hydrochloric acid. Again, note the pattern. Begins with hydro, ends in "ic", and then the chlor refers to the fact that it is a chlorine that is attached to the hydrogen. HF is hydrofluoric acid. HI is going to be hydroiodic acid, so always the same pattern, hydro, ic, and then something to imply the element that is combined with the hydrogen. H2S is going to be hydrosulfuric acid. HCN is going to be hydrocyanic acid. To name acids with oxygen, basically this is going to be hydrogen with an oxygen-containing polyatomic ion. Note there will be no hydro in the name, and the acid is going to end in "ic" or "us." Which one it is depends on the polyatomic ion. If the polyatomic ion ends in 8, the acid ends in "ic", and if the polyatomic ion ends in "ite", the acid ends in "us." A little saying to help you remember that: I ate it and became sick. I took a bite and became nauseous. And so if we have hydrogen with a nitrate polyatomic ion, so 8, the acid is going to end in "ic" and no hydro in front of it, so just nitric acid. Hydrogen in the nitrite polyatomic ion becomes nitrous acid. So again, "ite" and "us", 8 and "ic". And so if we look at H2SO4, hydrogen in the sulfate polyatomic ion, that is going to be sulfuric acid. Hydrogen in the sulfite polyatomic ion is going to be sulfurous acid. Hydrogen in the phosphate becomes phosphoric. Hydrogen in the phosphite becomes phosphorus. Hydrogen in the oxalate, again ending in ATE, becomes oxalic acid, ending in "ic". And the acetate, again note the 8 is going to end in "ic", and so that becomes acetic acid. So all 8s become "ics", all ites become "us" in terms of the names of the acid. When it comes to chlorine, chlorine has 4 possible polyatomic ions. There's the chlorate polyatomic ion, so that is going to follow the rules and become chloric acid. Chlorite is going to become chlorous acid. And not too surprisingly, the hypochlorite is going to become hypochlorous acid, and the perchlorate polyatomic ion is going to become perchloric acid, one of these 6 strong acids. Writing formulas, again, note if there's no hydro, it does contain oxygen. So these first 2 do contain oxygen, and if they end in "ic", the polyatomic ion is going to end in 8, and so chromic acid must involve the chromate polyatomic ion, which has a 2- charge, which means the hydrogen, which has a 1+ charge, will need to be doubled, or will need 2 hydrogens to give 2 positives to balance the 2 negatives. So the naming or the writing of formulas of these are similar to ionic compounds. Carbonic acid, again, no hydro in the name, so we're going to have oxygen, and carbonic refers to the carbonate polyatomic ion, and that has a 2- charge, so again H2CO3. These last three all have hydro in the name, and so there's not going to be any oxygen. So hydrocyanic acid is going to be hydrogen and the cyanide polyatomic ion, 1+, 1-, so that's a 1-to-1 ratio. Hydrosulfuric acid is going to be hydrogen and sulfur, no oxygen because the hydro indicates there's no oxygen. The sulfide ion has a 2- charge, so we need 2 hydrogens with the sulfide ion. Hydrophosphoric acid is again going to be just hydrogen and phosphorus, no polyatomic ion with oxygen because of the hydro. The phosphide ion has a 3- charge, so that is going to be H3P.